I welcome everyone for this day two session on well testing using MS Excel. So we already have one day that we have done earlier, and we have discussed about radius of investigation, skin, positive, negative, zero, and we have seen how the pressure disturbance will travel from wellbore to drainage boundary, and what is transient time period, and pressure drawdown test that we have conducted with data in Excel, and we could able to quantify permeability, skin factor, and radius of investigation. So we ended our session up to that, and today we are going to see something integrated with well testing and MS Excel, like some kind of data analytics. We are going to do that with integrating with well testing. So some part of well testing we are going to take like advanced testing techniques from build up to derivative. So generally we have discussed what is build up test earlier in last session. So we will go a bit advanced to that in derivative analysis. So with derivative analysis, what are the things that we were able to uh, get next to build-up test? That is one thing that we're going to see. And then we will be going with some techniques related to pressure transient test. One is derivative, and we're going to see how Excel will help you to integrate, and if there is any uncertainty gaps are available in the data, how to manage that data. Like sometimes we may not able to get exact or accurate data. Some missing parameters will always will be there. So that parameters has to be either adjusted, or you have to find a logic to give that approximation value. So how to do that? We will go simply, and when it comes to real time, so how we have to integrate these things that we will be going through today's session. And then one more technique that we are going to perform is production decline curves, like decline curve analysis. I'm going to show you the equations. So each equation is a derivation. So this has to be understood. Like directly we're going to talk about the equation, but it comes through a derivation. So we are not going to discuss about derivation, but directly we will go into interpretation part. So I will be telling you the differences and how to interpret future production. So that is what we are going to do today with that. Um, Reservoir characterization that we will be doing in derivative analysis, application of MS Excel in well test scenario in production decline curves, as well as derivative analysis. And even further, we will plan to construct, like as you have seen in the PPT. So let us try to work on a dashboard. So this dashboard part is common for most of the softwares in data analytics, could be Power BI or Tableau or Excel. So this is a kind of technique like dashboard, constructing a dashboard. Mostly we do for sales, like revenue data, sales data, that dashboards will be available. So let us try to see, we will try to do with that in Excel, and we will see how the outcome result could be. So that is one thing. And we will end our session by constructing this dashboard with available data, like whatever data that we have, based on that we will try to construct this uh, dashboard. So type curve analysis, production decline curves. So we have three types. So we will be seeing what are those. Derivative analysis, how to construct derivative curve. So yesterday we have discussed about drawdown test. We have constructed drawdown graph, and we have interpreted reservoir parameters. So today we have to see build up as well as derivative. Parallelly, we will try to see together in one graph, and we will see what are the things that it will give us as an insight. And data analysis, we will be seeing once you have Excel in front of you, I will be whatever drawbacks or certainties, uncertainties, gaps are available. So we have to observe that. Based on that, we will see what best we can do to manage all the things. So first thing that we are going to do is derivative analysis. So I will be doing this session in two parts. One is I'm going to discuss about the topics that we are going to perform in Excel. So we are going to discuss three things here. One is derivative analysis, production decline curves, and dashboard. So first we will be going through the theoretical part. Then after that, directly we will go to Excel. When we are performing in Excel, I don't think we will get a time to come back into PowerPoint. So that initially I'm going to complete this part right now. Then we can stay in Excel for full session so that it will not have much distractions. So the use of this pressure derivative type curve offers the following advantages. So when you see this curve, you have two axes on y. Like y-axis, you are having two things. One is delta P and derivative P. So delta P is shut-in pressure. Derivative P is that pressure derivative term which it has been defined through a formula. I'm going to show you the formula in Excel. So once you have these two datas, you will be getting two curves. So this is the one which is pressure buildup, and this is the one which is derivative curve. Time is common, that is shut-in time period, and which is in logarithmic. So both sides, this graph is log graph. So by you are supposed to construct a graph where you can plug in these two values. One is build up, another one is derivative. So once you get this, what is that initial observation that we get is you can see a hump. Yesterday itself I have discussed. This hump represents well-bore storage effect. So first thing, immediately after conducting this test, you will be witnessing this parameter, well-bore storage effect. Until the end of the hump will be continued as well-bore storage effect. After that, these points will stabilize, like it will be moving in horizontal way. Like we have to observe that the points has to move horizontal. So if that is the case, if you could see a straight line over here, then we can say that well have attained radial flow mechanism. So after well-bore storage effect, so well started to produce oil through radial flow mechanism. So for that, we need to see the point should be actually in a horizontal manner, like it has to be horizontal, like a straight line. Then after some time, it may deviate to top or bottom. Like you can see there are two arrow marks on top side as well as bottom side. So if it is moving to top means you can see here they have given an indication that permeability is getting reduced. If it is moving to bottom side, permeability is increasing. Want to use the laser? Okay. Permeability is moving, like permeability is decreasing. If this line starts to move like this way, permeability will be increasing if this line starts to move bottom side. And one more thing is skin effect can be observed by build-up test. Like you can see, this is the graph that is build-up graph. So it is, if it is moving towards top side, then if it is moving away from the trend, then that shows that skin damage is been increasing, means skin is getting more and more positive. So if it is coming down, then skin is reducing. So once skin is getting reduced, permeability will increase. So here there is like some gap is there between build up as well as derivative. So that represents your well is having a skin zone. So imagine the gap is less, means the skin zone layer is getting lesser. Like the gap represents the layer, like the damage. If gap is more, the damage is more. If gap is less, the damage is less. So this gap represents skin zone. If there is no skin zone, these both curves might overlap. Okay, this they may not exactly overlap, they could have some little difference, but almost they will come close to each other. So when you observe gap between buildup and derivative, that means the well is been affected by skin zone. So these are the things that we will be observing in real time. Whatever we have discussed, one is wellbore storage effect, radial flow, and skin factor, skin zone, whether it is increasing or reducing. On the other side, we will be seeing permeability is increasing or decreasing. So we can see permeability decrease if the points move towards upward side. It will be increasing if the points move towards downward side. So even not only here, even here also we have an indication. If pressure buildup is moving to topward, then that indicates permeability is reducing and skin is increasing. So downwards will be opposite to that. So this is about pressure derivative test. So you can see if you overlap drawdown built up together. So this is how the graph looks to be. As I said, well-bore storage hump. So this hump represents until the end of hump, you can have to see, you have to calculate the time. So the elapsed time, that is the end of your well-bore storage effect. Yesterday we discussed what is well-bore storage effect. So this is what exactly is the time that the well is being affected with well-bore storage effect. As you can see over here, after that it attained points in a stabilized manner, like it is moving in a parallel way, like just like horizontal way. So that represents radial flow. Then after that, the point started to move towards top side. If you can see there are two lines are there. One is dashed line, and the other one is linear, like straight line. So build up if it is moving downside, and drawdown if it is moving top side, then you can identify that condition as pseudo steady state flow condition. So where permeability is getting reduced. So this is what we have understood. Like you can see here, the buildup is getting going down. If the buildup graph is moving, like the derivative of buildup graph is moving towards top side, means permeability is been reduced. That is what we have seen in the earlier stage. But for pseudo steady state flow, buildup will go down, drawdown will go up. So this is another parameter. Like if you have drawdown and buildup both datas together, then when you construct this derivative graph, you have to overlap both on them, then we can get this information. So for build-up graph, you can see pressure buildup is getting raised. So what does that indicate? When pressure buildup is going towards upward side, that indicates skin zone is increasing and permeability is reducing. So this is about pressure derivative analysis. So there are so many parameters that we can interpret through this, but currently we will go with this. Then this is the data that we are going to use to estimate these three parameters. One is skin, radial regime, and well-bore storage effect. So you can see shut-in time period. So shut-in represents that the well is going through build-up test. Why? Because shut-in time period, pressure is increasing. So during shut-in period, when pressure is increasing, that represents you can able to get the pressure graph for build-up test. Then analysis for that, P plus delta P by delta T. So delta P is shut-in pressure, delta T is shut-in time. So P is initial pressure. Then the slope for all the pressures. So delta P, so you can see here, I have given different, parameters for this. For shut-in time period, A, delta P, B, P plus delta P by delta T, C, and the slope is D. So formula I have used is delta B by delta A. That we are going to see it in Excel. So don't need to bother much in the presentation. Then after that, this is the formula that we are going to use the value to get pressure derivative terms. Like, all the pressure derivative values, we got it by this value. So D1 plus D2 by 2, C into A square by 50.75. So 50.75 is the production time period. So that is the reason it is a constant value that will not change all through these parameters, but other values will be changing. So D1 represents the values from the slope, D1 and D2, and C represents the value from P plus delta P by delta T, and C and A represents the value from shut-in time period. Okay, so once you have the data in front of you, we can able to get all through this. So this is about derivative analysis that we are going to do it in Excel. Then let us go to production decline curves. So these are also very important a technique that we are going to use to estimate or forecast future production. Like you might have some years of data, probably around 5 to 6 years of production data that you might have, but you have an economic limit. Every well will be having an economic limit. Beyond that, the production may not provide you commercial profits. So you are supposed to either end the production, or you have to stop for some time so that later you can continue the production. So where that you need to know at what time period this production is going to reach to that economic limit. For that, we are going to use production decline curves, which is an important parameter for forecasting how many how much time. It could be either months or years. So where exactly your production is going to get declined. And you might have an economic limit. Imagine if your well is producing for 50 barrels per day. So below that could not be a commercial uh, prospect for business. So for that reason, we need to, currently you might be producing around 350 barrels per day, but it is getting declined. But at what time period you're going to reach to that economic limit? So that that forecast can be done by production decline curves. It is a reserve estimation techniques. We have three techniques are there. One is volumetric, material balance, and production decline curves. So the one which has more prominence is production decline curves, and we are going to have three types of it. One is exponential, harmonic, and hyperbolic. And this came through Ops equation, and this is the equation for that. Flow rate of gas or oil with respect to any time level. Like you are supposed to specify time limit over there at T. That is equal to QI. I represents initial period. So flow rate at initial conditions by 1 plus B DIT power 1 by B. So B is an exponent. You can see the values will change when you are using different curves. Like we have exponential, harmonic, and hyperbolic. So the value of b for exponential will be 0, which is almost linear. Then for harmonic, it is 1, and hyperbolic, it might be in between 0 and 1. It could be around zero point 0.1, zero point 0.2, or 0.11, zero point 0.2. We can't say that. Why? Because this value you are supposed to define to get that trend of or slope of that curve. So this is something which is bit more you need to do more data analytics for this. So let us see. And DI represents initial decline rate. So this is a kind of initially what is the decline rate of the data. With that data, you will be getting a specific value. Based on that, you can start constructing this equation. Okay, this is one is like B is unknown, DI is unknown. Probably the data might have flow rate and time period. You are supposed to define B and DI. With that, you can construct modeled equation. It could be either exponential or harmonic or hyperbolic. So you are supposed to choose which one is the most suitable for your current data. How to choose that? So imagine you have real-time data. So you're supposed to put on the graph where y-axis is flow rate, and time will be on your x-axis. See, imagine you have a time limit, like up to some extent you have the data. That could be, you can see a red line, which is the real-time data that you have. So the flow rate is reducing when time is progressing. You can see time is progressing in x-axis right side, and flow rate is reducing in this vertical side. So flow rate is reducing when time is being progressing, but it ended at the blue line. So probably at this time level, you have the data. Beyond that, you don't have. Probably this is the time level at current time. So from today's time onwards, you are supposed to predict future production. So since it is reducing, you know that it might reduce in next few days. But you cannot exactly tell at what time period the production will reach to the economic limit. Imagine you might have drawn economic limit somewhere around here. So here it could be high, here it could be low. maybe around 20 barrels per day, 20 standard cubic feet per day, or anything you can take. So that is your economic limit. Like if I could draw a line, like not like straight, you are supposed to draw a straight line, not like that. So just try to draw a straight line. So let us say this could be your economic limit. Right now, this curve has to progress forward and it has to meet that economic limit. From that, you are going to measure the time level. So that indicates that your production is going to reach to the minimum time level. How we can do that? Like that can be done through these curves. So one is exponential, another one is hyperbolic and harmonic. So we are supposed to use the real-time data and we need to import the data from real-time to the ops equation so that you will be getting modeled equation. With that, if you start constructing, you will be getting three different patterns. One is exponential, harmonic, and hyperbolic. So you can see orange one represents exponential, green one represents harmonic, and hyperbolic is the one which is in purple color. But by seeing this, you know that the best fit curve near to your real-time data is the one which falls under harmonic. So there is no need to choose exponential and hyperbolic. Rather, you can prefer harmonic. Why? Because the trend is close to your real time. Okay, almost it fits. It may not be 100%, probably around 95 to 100%. You can accept that difference. So if it is fitting up to that, then from that onwards, you can start moving towards the forecast. Like you are supposed to move towards future production. So you can see this green line is meeting your economic limit at this time level. In that way, we can able to estimate the time where exactly production is being declined. And you got to know the value of the economic limit time level. It could be either days or months or years that we have to define. And today we are going to do this, like we are going to see this, but constructing these three curves might take a bit long time. Rather, I will try to simplify with one particular curve, and based on that, we will forecast forward. And matching that curve may not be possible today, but we will be seeing how the forecast will be done, and we will try to get that value of economic limit. Then other curves also it can be forecasted forward. Like you can see that will give you some different values. As per exponential, the forecasted economic limit time is over here, and for hyperbolic, the economic time limit is somewhere around here. So which may not give accurate results. Rather, you are supposed to see where exactly this green line is touching. Why? Because this is the one which is having closer proximity towards your original data. So based on that, you can forecast with your harmonic curve. So this is how we can do. And these are the production decline curves. Like altogether, they are 12. So three curves with different axis units. Like one is Q versus T, like linear flow rate versus time. And the trend of the curves looks to be like this: exponential, hyperbolic, harmonic. Log Q versus T, the trend looks to be like this. And Q versus cumulative production, this is how the trend looks to be. And log Q versus cumulative production, this is how the equations looks to be. But if you observe these equations, no line is passing through horizon. So you can see any of these lines are not passing through horizon. You can see it is not touching any horizon. That means these can be represented as a straight line which can be fitted with y is equal to mx plus c. So all the lines will fit in that equation. Y is equal to mx plus c. So we are going to use this equation term to define the values of those exponents that I have discussed earlier. One is b, another one is di. So we will be seeing to that. And the equations for that exponential is ops equation, which will be used in the term that I have discussed, y is equal to mx plus c, you can see that our equation have been converted to y as log qt, x as, sorry, this is the c, which is intercept log qi, minus di by 2.303 will be m, which is slope, and the t represents x-axis. So t is your x-axis and the log qt is your y-axis. As you can see in this graph, log q versus t. The slope of the curve will be minus di by 2.303, and y-axis is log q, x-axis is time. So this equation can be fitted with your straight line equation. By this equation, you can define the values of either b or di. For exponential and harmonic, you don't have to define the value, already it was given. But for hyperbolic, you are supposed to define the value of b. But d value, no equation has specific di value, so you are supposed to estimate that. So with that, we will be doing production decline curves. And next to this, that we are going to see this in real time, and we are going to use the data. This is the data that we are going to use. Time you have, flow rate you have, and these are the values. And we are supposed to create a model of exponential in all the three curves, like harmonic and hyperbolic. Currently, we will be not doing, but currently we will go with exponential with real time. And we will see the forecast. So we're going to use these two equations for that. And predicted time economic production is up to 50 standard cubic feet per day. Means you can see that production is declining, but we don't know at what time you're going to reach 50 standard cubic feet per day. So that is the one which we are going to, today we are going to estimate. So this is the second thing that we are going to do. And third one is dashboard. So you can see a data was given over here, well test data. You have all the parameters. Date value was given. This is the date. So all the days according to the time level, flow rate pressure. But you can see some gaps are available here. You can see there are number of gaps are there in the table. Like pressure, we are missing a data over here, and permeability values are available, and saturation is yes. So here also some gap is available. Flow rate, which is increasing when pressure is reducing, and formation volume factor, oil prices. These are dynamic values which are in dollars. Like N represents the amount of reserves. It could be barrels if it is oil, or else it will be cubic feet if it is standard cubic feet if it is gas. And the revenue that was generated, and FC represents fixed cost and VC represents variable cost. After deducting these two values, you will be getting profit values over here. So this is the dashboard that we have. And by seeing like this, we may not able to get any insight. Rather, we need to create some visualization effect so that it can be easily understood. If someone have to know what is the profit at a particular permeability around 200 or somewhere around. So you're supposed to search where exactly is 200. So 200 values are here somewhere, and corresponding to that, the profits has to be checked. But if this with certain parameters, if it is connected, then it will become more difficult. For that, we are going to use, that kind of visual visual technique, data dashboard. So that we are going to do. So this will be the last task for today. So let us get into Excel and we will start working on one by one. So I hope whatever the task that we are going to perform, I'm clear. So directly I will start working with the first one. First one is pressure derivative analysis. So this is the one I'm going to generate. So I'm going to just remove that. So you can see the data was given shut in delta P, P plus delta P by delta T, that is C. And this is the data that I have shown you in the presentation. I'm going to remove that and I'm going to solve once again so that it will be easier to understand. So data, what I have shown in the presentation are few points, but generally, data carries more. Okay, so first of all, we are supposed to estimate the value of slope, and then how the points from slope we can get the values of pressure derivative that we are going to use this formula. So initial stage of slope will always be zero. So you can take that point as zero. And after that, delta B by delta A. So B represents shut-in pressure and A represents shut-in time period. So delta P, it is the difference, like B2 minus B1 by A2 minus A1. So you have the value of slope and double click on it. So you have all the values of it. So this part was completed. Then let us go and estimate pressure derivative terms. So here d1 plus d2 by 2. So d1 is the slope values. So these slope values average of earlier value and current value. So I can easily use the formula as average. So click on average, select those two values, close the bracket. After that, multiplication term parenthesis into, open the bracket, C. C is the value which is represented as P plus delta P by delta C and into A square. So A is shut in, power 2. Power 2, close it and close one more bracket that completes, no need for that. Rather, you have to subdivide that with 50.75, which represents production time period, which is constant, so that we are putting directly that value 50.75 and equate it. So you have the value of first one. From there, the values will be continuous. So this is your derivative curve. So anyway, initial value will always be 0. So let us keep as it is like that. Then shut-in time period plus delta P. So you can see, let us try to construct this, insert. And when you construct a graph, this is your actual pressure buildup graph. So you can see we have already discussed about it in our earlier session. Pressure buildup. So let us keep this beside, and addition to that, we are going to include one more column to it. Then insert, go for estimate. So this is your actual pressure buildup is on the blue curve, and orange one represents pressure derivative. So I will be keeping somewhere around here. So this is the one. Let me make it big. So this is actually your pressure derivative graph. Pressure derivative. So as we have discussed earlier, so we are supposed to estimate, one is wellbore storage effect, second one is skin zone, third one is radial flow, and fourth one is permeability, whether it is increasing or reducing. So these four things that we are going to see over here. But as I said, this is linear graph. We are supposed to convert into logarithmic. So let me convert my x-axis to log. It is asking that option. Just convert to x-axis as log, as well as even my y-axis is also should be converted into log. So you can see easily that trend have been adjusted, and that y-axis is somewhere around here. So let us try to adjust this value. I'm going to click on y-axis, go to labels, and just click as low. So it will not be inside the graph. So this is how the graph looks to be pressure derivative. And you can see a hump. You can see a hump over here. And after that, some points were attained to be radial. Then it started to move towards a bit upside. Like you can see that the trend is started to move towards top side. And as well as build up also, it is moving like, slowly it is inclining. So that represents that the production is affected more with skin, like skin zone is affected more for production. And permeability is reducing. Okay, so first of all, let us try to define one by one. So for that, what I will do is I will insert a shape. I will just take a random shape. This one, I will connect all the points which fall under Then I will try to make it in a color. Like, just let me just give this color. So this could be the region for Velbor storage effect. So I will be writing as Velbor storage, and I will change its color to be black, so it's easier to identify. So this is the part where Velbo storage is, like, you can see that kind of hump over there. And moreover, we can even witness by adjusting the transparency so that it will be easier to understand. Like, I will not give direct color, so let it be up to here. And this is about Velbo storage effect, and some line we can keep. Yeah. Then after that, we have attained some stabilized points. So what are those points that have attained stabilized point? For that, we need to use another shape, that is, I can use this value. So you can see these are falling in this straight line. I'm going to use black curve, and I will increase the weight for this. So what are the points fall in this straight lines comes under radial flow. So this are the points which represents that well is being witnessed with a radial flow mechanism. So I'm going to insert a text box near here, which represents radial. And these are all the points that were impacted by skin effect. Like if it is moving towards top, the permeability has been reducing and skin has been increasing. So these are all the points which started to deviate from the radial flow behavior. So, and not only that, and as I said earlier, if the gap between build up and drawdown is more, that indicates that the well has been affected by skin zone. So you can see this is the damage that the well is having currently. So even we can represent, if the gap is less, then the skin effect is considered to be less. Then from here, we can include one more text box indicating that the well is been affected by skin layer. That is one thing. And um, one more thing is, so here actually the graph is shown that the pressure buildup is moving towards top side, like it is inclining. That represents skin is increasing. Like this is the layer, but continuously it is increasing. So this is what it affects. In the same way down also, from radial side onwards, the production, like permeability started to get reduced. So this is skin increase, this is permeability reduction. So these are the indicators for that. One is rise in skin, and another thing is reduction in permeability. So these are the things that we could able to define with the pressure derivative analysis. Like currently, these are not complete analysis. So many things are there that we can do it. But currently, with the help of the data that we have, we could able to create some information. So these are the insights. One is wellbore storage effect. After that, radial flow. Then what is the skin layer? Like what is the damaged layer in between them? And when progression is there, skin is rising and permeability is being reduced. For build-up test that we have seen, pseudo steady state flow means it has to move towards down, and drawdown has to move towards top. But it is not actually moving down, rather it is just deviated towards, from radial side, it has deviated to top. So these are initial interpretations that we can do with pressure derivative analysis. So let us go to the next one, that is production decline curves. Let me quickly take you to that. So this is the one which represents production decline curves. So I already kept the data, time in days and flow rate, which represents gas flow rate, standard cubic feet per day. So you can see this is the data that we have. And I'm going to first construct actual production data. So I selected all the values, insert. So you can see the data for production. The production has been declined. And as we can see that 50 standard cubic per day is the one which we are going to target. Like at what time, at what days you are going to reach that production levels. That could be the end of your economic limit. So let us keep this beside. So we will try to use this equation to do that. Quickly, I said that this equation can be represented as y is equal to mx plus c. So m is minus di by 2.303. So I have written that value here. M is equal to minus di by 2.303. Intercept is log qi. That also I have written here. And x-axis is time and y-axis is log q. Sorry, log q comes here. This is the graph where is log q. Log q is on y-axis and x-axis is step. Okay, that's right. Okay, so let us try to estimate the values of what are the things that we require. Is this is the model equation. Qt is equal to qi into exponential of minus dit. So qi value that we have, that is the initial flow rate time, that is 413.3. Then what is initial decline rate? So this is the one which we are supposed to estimate. And how we can able to do that? By using this equation. Slope value m is equal to minus di by 2.30c. This is the equation that I'm going to use. So what is m? As I said, in the equation y is equal to mx plus c, m represents slope. Between what? X and y axis. What is x axis? That is time, and y axis is log qt. So both axes you have, x is time, y is log q value. So I'm going to put the value m over here is equal to, I'm going to estimate slope value slope. This is the function that I use. So it is asking y-axis. So what is y-axis over here? So y-axis is log qt. So I cannot use directly this values. Rather, I will use the term as log, open parenthesis, select the first one and go to last. So right now you have selected your y-axis terms, comma, and go for x-axis. X-axis is linear. Directly select all the values. Close the parenthesis and enter. So right now you have the value of slope. And once you get the value of slope, you are supposed to define the value of di. So you can see m is equal to minus di by 2.303. So bring di to LHS side so that the value you can estimate with m into 2.303. So you have the value of m already here. So that value you can put it for d is equal to minus m, minus of slope value into 2.303. So you got the value of initial decline rate. That's it. Like you have all the values, like QA you have, DI you have, and the time you have. Then just construct the modeled equation for exponential is equal to QI. Select the value of it, which is constant. So use function F4 to make it constant into E. E represents exponential, EXP, open parenthesis, minus DIT. So what is minus DI? Minus of DI value into time level. So select that value. And again, this DI is constant. Function F4 equated. So you can see the values are almost close to each other, 413 and 409, and double click on it. So you have all the values of your modeled equation. So this is the end of it. But what is the target that you have? 50 SCF per barrels. But here you are reaching up to 91.1. So let us see how both will, compare with each. Let us compare both curves. So we already constructed the real-time graph, and right now we are going to include the modeled graph, that is exponential. So I selected all the values, insert. Let us see with the, see, you can see how these values were constructed. So the blue one represents your real time and the orange one represents exponential model time. So let me try to change both towards line graphs, so it will be easier to get it. So you can see uh, the one which we have generated is the one in orange, and which is representing exponential curve, and the blue one is the data that you already have. So from here onwards, you have reached it to somewhere around 90. But right now our target is to reach 50 standard, 50 cubic feet per day. So for that, what we have to do is, here we don't have real-time data. Rather, you can forecast from, you know, the modeled one. So how we can do that? For that, what we can do is, this is the time that we have, and let us increase the time. Like generally, Excel will be having some time, and you can just increase it up to whatever extent it is. Just go on increasing it. Select either 2 or 3 or some trend and let it go on increasing. That doesn't change anything in the slope. So if you have the time parameters, these equations, you can see it is using the time level, and then it is forecasting forward. So for that reason, I have extended the time limit there. Then right now, I will just click on the last value of your modeled graph and double click on that. So you can see all the forecasted production values that you have. The one which you are targeting is 50. So you can see somewhere around here could be the value where you can reach. So let me expand the values of these things. So select both up to here, and again select uh, the modeled graph up to last, and insert, go to, you can see the forecasted graph can be seen exponential. Exponential forecast. So up to here is your real-time data that you have. Then after that, the production started to increase. Just a minute, I will be. If you start constructing a straight line near to the economic limit. Let us try to see. So there is a grid over here. So you can see this is touching up to here. So this could be the one time limit with exponential. So this is the time where you're going to reach exponential, economic limit. That is around 50 SCF per day. So this is how we can construct exponential forecast. Let us start working on the last topic, that is dashboard. So let me directly go to dashboard graph. Yes, so this is the one which the data I have shown over there. So for constructing dashboard, like how to construct this, we already have some gap values of this. There are some gaps are available here. So what is that we can do? How to, fill these gaps? There are somewhere here, somewhere here. You can see so many gaps are available. So there is one thing that we have to, when we have to use dashboard, when the data is having more random values, like how to know that we are having random values. So you can use a term like select all the parameters, go to all the parameters that you can select it, and just click on color bar. So if you click on this color bar, it will give you some indications like green and different colors like red and yellow, all are available over here. So these values represents high values and low values. But you can see the values like time. It is like reducing and finally it is reaching this value, but it is not going to green value. You need to see three colors, 3 to 4 colors. But why it is coming like this is it will take the highest value of all parameter to be the highest and lowest value of all parameter to be the lowest. So actually we don't want that. We need to know each parameter highest and lowest values. For that, what we have to do is, let us take pressure points, select all the points, and you just try to give color variation. So you can see all the colors that will exist. So you have to do like that for all the parameters, so which would take some more time. First of all, here what we have to see is we don't know whether the data is having random data or not. So first one is not random. You can see the values, the green one represents the highest and red one represents the lowest, which is like continuing. Even though if you increase the time limit, it will continue. So this is not random values. Let us go with permeability, select all the values. I will go up to the last. And let us see whether it is having some random values. Yes, you can see the values are random. Why? Because it is not showing that linear change in color. Rather, it is giving random, blue, red, I mean, green, pink, yellow are combined over here. So which represents that the values are random and we are having a lot of gaps also. So that means when there is randomness, then we can go for constructing dashboard. Why? Because that will give you a good indicator. And even saturations are random. Flow rates are not random, I think, but formation volume factor is also random. Oil prices are random. So based on that, other things are interconnected. Okay. So first step from this dashboard is let us try to fill the data here. So select all the values which are having gaps like unfilled cells. After selecting all the values, don't select the topmost cells. Why? Because those are headers. So let us try to select until numerical values. Go down up to here. After selecting it, just type Control G. Then you will be getting an option like go to and click on special and click on blanks. So this function will help us to know where the blanks are available in the data. Click on it. So you can see all the blank cells have been highlighted. You can see there are like blank cells have been highlighted. So first of all, we need to fill this data. For that, what we have to do is imagine pressure values are reducing and probably this value will be less than this, but it will be more than this. Rather, I can take average values of earlier two values. So that could be the one which will be my best fit. So if you have any other logic, you can use that. But currently, earlier two values average, I can fill in this cell. In the same way, saturation also I have to do that. Since even though it is random, but we have to use average values where the empty things are available. So empty cells are available. So the same way, whatever cells are there, I'm going to use earlier two values to make it average and fill over there. For that, what we can do is click on equal and type it as average. You can use anything, standard deviation, average. Currently, for this scenario, I'm using average. So I'm clicking on average and select how many points you want. You can select either 3 or 2, anything. Just select 2. Close it. And right now, type it as control enter. So you can see all the blanks have been filled up. Then after this, the next step is to construct dashboard. For that, select any cell, just any cell, go to insert. We can construct Excel dashboards through pivot tables. So click on pivot chart. It is asking you to select the range. Already it has selected the range. You can see the dashed lines. It is selecting all the ranges of it. And it will be showing my dashboard in new worksheet. You can do the same in existence, but let us go to new worksheet and click on OK. So it has taken me to new worksheet. So this is the chart table, but let us remove this for time being. And these are the columns that we can use to create the dashboard. So here is the one which it is going to show. First of all, I want to use filters are those things, specific values if you give for that, what could be the data. So for that, I'm going to use saturation. You can see you have even oil prices also available. Anything you can take which you are more specific about. Profits you want, you can take it. But I would like to take saturation values. So I'm going to keep it over here in filters. Then even I can use date also as filter. I want two filters, so I'm using two filters as this. Then my x-axis, here we have x, y-axis like rows and columns, and values will be observed in that direction. So let me take rows column as like I want to see actually the revenue part in values. I want to see revenue part in the values. And let me just take pressure values on y-axis. So here actually the pressures were adjusted like this, but generally you need to ungroup it so that it will give you the right value. It's not, just a minute. To generally this is how the value looks to be. Yes, it is overlapping with earlier data, so that only it was not ungrouping. So I have removed that dashboard, so it started to okay then. So rows values were fixed over there. Then let me put the permeable values on column side. So you can see the revenue values were in between the column values, which represents permeability, and row values that represents uh, revenue. The row values represents pressure. So these are all representing pressures. and these are all permeability. So permeability values, you can see 200 to 299. That could be the minimum value, 300 to 399. And in between, anything you take, like the pressure value over here, permeability values here, the revenue it is generated could be around $63,559. So the sum of all the values in between will be giving you at last. That is the grand total. So this is how the values can be adjusted, like at different pressure and different permeability. So let us try to, like this looks to be a bigger one. So let us keep it even more better. So for that, select on rows, click on group. So this is the minimum value starting and ending value. And we don't need this much decimals. They can remove this. Let us have some divisions in between. Let us take division around 500. Like after the starting value, next to 500th value, like starting value plus 500. What will be the value? That will be the next outcome. So if that is the case, this is how it looks to be. But even 500 is giving very this one. Rather, I will go with less than 500. So it could be around 300. Okay. So 300. So all the 300 divisions will be adjusted over there. Then when it comes to permeability, no need for 10 divisions. Rather, you can group it around 300. So right now, the divisions were in like 200 plus 300, 500. So like that, it will be adjusted. So on this side also. Let us try to give color variables to this. Anything, add colors. So we will be knowing which one will be having the highest value from that. So let us take the white one as, no, let us take the red one as the highest value and white one as the lowest value. So in that way, the highest values were exactly the weightage. The temperature will help us to know where are highest values. So after this, what we can see is select on any cell and go to insert and try to see recommended charts. How many recommended charts are available? Like it will give you different insights with the same data. So go for bar graph or somewhere around here, and let us select one graph like this. So adjust the value nearby. Can remove this. This is one graph that we have, and you can remove the axis. Already the colors are representing over here. There's no need for axis. Even the grid lines also you can remove it. Then again go to insert recommended charts and go for another method. You can select whatever like graph that will give you insights. Like I'm selecting few graphs with that, and this is one graph. I'm going to give some space here. Then after this, insert. It might take a bit time since we need to see all the visuals, what is possible. Even you can adjust the you know the angle since it is It may give you different values to that. Like if you want to adjust the values, you can adjust it. Then the parameters that you are interested, just click on it and go to, let's click here, sparkling. So this one column. So I'm selecting the data and I'm selecting the location where exactly it was supposed to. Let's click on it and expand the graph. Then I'm going to use timeline to see all the changes. Since timeline we have adjusted, so select any cell, go to timeline, and we have date as timeline. Click on it. So you got the timeline over here. So you can see there are different time levels at different scales. Like even in this timeline, we have different parameters. Like in months, it was showing. You can use quarters. You can use days. Like it depends. Like days are more, so you can expand the timeline. Like you can see, like you can change the color if you are interested. So let us try to keep the timeline as it is. Then not just about timeline, we need even more parameters. So click on the cell, go to pivot design, and insert slicers. So these are all the slicers that will justify the need that you require. Like no need to select those parameters that were already available in the data. Rather, you can select any other parameter which you may interest. Like oil prices is the one which we haven't kept over there. So revenue we kept. So oil prices is one slicer, and amount of production, variable cost, profit is already available, I think, inside, and flow rate. So how many saturation as a filter we are having. So I think these are enough. So you have different slicers. So let us try to keep wherever empty space is available so that it will try to, adjust all the values. Oil prices, so you can give different colors. Rather, you can just increase the dashboard size so that you can fit all the values. It take a bit time since we need to construct all this. It all depends on how you visualize your data dashboards supposed to be. So this is currently I'm doing it, but you can customize like whatever you are interested of. I'm going to give different colors to each slicer. Um, these three are okay, and try to meet all the edges so that there won't be any space. That may give you a better inference. Okay, probably I may give this value to be okay. So I will reduce a bit size to be observed. Okay, we are done up to here. Let us see, this is a kind of a sample that I have generated. So let me just try to see the parts that we can do. So I will be keeping the values in months. So here what I can do is, you can see these three are those variations that we can able to understand, and the remaining are all the parameters of your interest. Let us go for January month. Click on it. So all the values will be adjusted according to the one which is January. So you can see the permeability variations in between pressure and revenue. So you can go for February and you can select 3 months together, and this is April, this is 4 together, and you can, uh, if you don't want, you want to see everything together, then click on this button so that it will be clear. And right now you are interested in certain things, like in slicer you have oil prices, all the oil prices above 78 alone. So you can see the changes. And if you want to see, if you're interested in any specific value, like you can select one over here. So that will give you exactly specific value for all the readings, and increase the range. So accordingly it will be adjusted. So that also can be, and variable costs. These are the one which you can adjust actually. So it depends, like you can select all the variable costs accordingly. It will change, go back, and flow rate. So when you are giving a slicer, it will be in ascending order. So you can go and select the flow rate values. So accordingly, it will be adjusted. So as per the changes that we have, it will start being adjusted. Like you can select together also, specific values also you can get select. If you don't want, if you want to make it idle, let it be as it is. So this is the one which we can generate. And one more thing, since I added filters here, I want to see, uh, there could not be much saturation values. Let us see how many saturation values are available. Yes, you can see all the saturation values, but if I want to know these data for a particular specific saturation, I have to click on it and I have to take it on OK. So I will be getting this data with all visualization tools. But I want the data alone. I don't want this one, but I want the combination of these three values for each saturation. For that, what I have to do is just click on saturation, go to pivot table analysis, go to option, show report filter page, and click on, so you can see the values of saturation that we already have. I'm going to click on OK, so that what the outcome that will be expected is, for all saturations, you will be getting this combination result, but not with the graphs that we are seeing here, not the dashboard, but these three, like one is permeability, another one is pressure, and the one which you are seeing inside is revenue. Just click on OK. You can see the page number was given, so you can see different sheets were created. In an instance, you could able to generate number of reports for each saturation for that combination. I think you are observing all the saturation sheets were created. 0.9 saturation, 0.2, 0.21, 0.22. You can go and see like all different saturation, all the saturation values. So this is actually the dashboard. And not just about that, the same thing you can do with dates also. Click on it, go to options, show report filter, select the date and click on OK. So you will be getting all the dates. 1/1/2022. This is the report. You can see different dates. You are having different reports. The combination that we have selected, that alone will be shown. It is up to you to select all the combinations. So all the sheets with reports were generated. So number of dates are available, I think. So many reports have been given. Yes, finally we came to the dashboard. Yeah. Okay, and that is the session for today.